Everybody, and welcome to the BIM for Buildings webinar. My name is Glenn Sinclair. I'm a technical consulting lead with A2K Technologies, and just run through the agenda first up. So we've got about an hour for this webinar and quite a bit to get through. I'm going to go through an introduction first off to A2K Technologies and to myself. Then we're going to move into modelling and context with the new FormIT tool online. Going to talk about taking that model from FormIT over into Revit, then how we can work with that model and massing models in Revit to use them for analysis. We're going to go through the concept design phase using the Building Design Suite for presentation, both with rendering locally and on the cloud, and then look at some smarter documentation techniques using the BIM tools. Then I want to leave a bit of time at the end for some Q&A. So I'll be covering over these topics fairly quickly, but if there's anything that you see that you'd like to know more information about, I'll give some details at the end of how you can either request a further webinar or have us come out and see you for a bit of a demonstration. So first up, intro to A2K Technologies. We're the largest reseller in Australia and New Zealand with over 150 staff. So if we don't have someone near you, we can definitely fly someone to get out there and come and see you. We don't just do the Autodesk products. You can see there we do everything from Microsoft to HP hardware. So if you needed a one-stop shop, we'd be able to get the hardware ready for you with Windows installed and potentially the full Autodesk and Adobe suite pre-configured and out to your office. And so it's not just software that we do. We, as you can see there, we also do the hardware side, a lot of consulting and training as well. So it's not just software sales. And myself, so Glenn Sinclair, as I mentioned. My background is as an architectural CAD and BIM manager. Most of my experience with Woods Bagot there, some very large studios and projects to deal with. So specialising in large project establishment and studio management there. So I've worked on everything from the very small to the very large in my time. And my first little Revit projects there, the Cairns Institute in Cairns there. Alright, so we're going to get started with looking at the FormIT tool there. So this is a tool that's designed to be able to model in context of the design. So I'm going to show it in its online form. It is available as an iPad app, but we're going to have a look at it here. So we Google it. So we've got Autodesk FormIT there. So this, as I said, is available on iPad and for Android as well. But the version that we're going to be using is the beta version of the online tool. So if I click the button there, it's going to open up the window showing us the browser-based tool. And of course we agree to everything. Alright, so when you first open up the tool, it doesn't look like much. We've just got a blank canvas here. But one of the real powers of the tool is being able to import the context of your job there. So if we hit the little location button, we can do a search for our site location. So if I just put in our office address here in the city, ooh, that is not it. There we go. Is there another Collins Street in Melbourne? Well, that's a bad start, isn't it? Usually, pretty good at picking up the old location. Is it called? Does it think we're in Docklands? No, I wouldn't have called it Docklands. All right, so there's our office address there in the city. So the site that I'm going to be using as my little demonstration is this site next door here. So I'll just drag the pin over onto that site, and we'll use the set location tool to set that. On the iPad, there was the little button there for the use my location, which is going to use the GPS sensors there to decide where you are in the world. So when we click that button, we get the site context there on the ground. We can see the surrounds there in a bit of a 2D map, and it's also brought in the weather data and the true north location from that map. So one of the first things that we need to do is actually get our units set over from imperial to metric. Set over, and now we're pretty much ready to go. So the web version is a little clunkier than the iPad version, but it gives us the precision of using the mouse rather than having to click with our fingers. But so to get things created, we just click the Create tool here. We can either create solid forms or use rectangle forms and extrude those up to create solids. So if I use the rectangle tool there, I can drag across for my width and then drag the box there for the depth. So we're going to say it's going to be the full site. So once we've got that initial shape, we can just click and drag with the mouse to start giving it the height. And so as you can see, it's by default just given us the shadows on and things like that. Just popped some quick shading around the our little project there. So if we continue on and do some other bits and pieces here, fairly limited tool set that we've got. Just a few basic shapes and objects. Whoops. So nothing to compete with any of the advanced modeling tools, but the power is that we're doing this in context. So if I start off with the basic cylinder here and just use the zoom wheel on the mouse to start playing with the size of the object, I can double click to get into editing individual surfaces of those objects. And again, we can still use the scale tools to adjust that too. So that was just with zooming in, using the scroll wheel, sorry, on the mouse. So here we have by default just the sun settings at whatever time of day we may be. If we have a look at the little sun settings here, we can start to change the time of day, move the sun around. But I believe this may not be entirely accurate for the southern hemisphere. Again, it may be a little Americanized here. I happen to know this site, and we should be, this direction here is east, but it seems that the sun's coming from potentially the opposite direction, so it might be a bit of a fail for us down under there. But yeah, you can see the shadows moving around there. We've got the settings here for the different display styles. So at the moment it's just set to normal presentation display, but we can show the lines beyond the objects and a few other basic options there for making it look like a bit more of a presentation model. Yeah, so once we've got something modelled up, again, potentially on site, potentially something very quick, we can, I guess the power of this tool compared to some other tools is that we can actually make use of this object. So when we go to try and save the model, it's going to ask us to log in to FormIT, and that's using your Autodesk ID. If you've got the Autodesk 360 ID, it's going to be the same one there. And that is going to give us a couple of options. We can either download this model, or we can actually get it to save to our Autodesk 360 account. So that's pretty handy that we don't need to actually download. We can just save it straight onto our Autodesk 360 there. So I'm going to save that one. Oh, no, how do I get it downloaded? I thought it was that guy. Gallery, how do I get this guy downloaded? So we can get this model downloaded, ready to go into Revit. That was material options. What was that guy? Yep. Not going to let me export that guy. All right, fine. That's correct. I'm not sure why I don't have my export option available there. It's a bit silly. Come on. Never mind. All right. Yes, we're signed in. Issues. So anyway, so we can get this model downloaded. I thought the button was right there, but maybe not. And we can then open this context model up inside of Revit. So that's sort of the power of using FormIT, is that we can take this initial sketch model a little further than just discarding it. We can actually use that as the context model for our Revit model. And one last go. What's going on here? Can't see most of these tools. Okay, we're going to flag that. So do I have an example? No. All right, so we can, believe it or not, bring this model into the Revit environment. We can open that exact same model in Revit, which is nice. It does save from FormIT there as an Revit 2014 format file rather than the 2015, but that's fine. It's just going to update as you open it up. Didn't automatically go in there. FormIT. Oh, there we go. So there is a download button somewhere, but I do have the Autodesk 360 Sync app installed here, so everything from my 360 account comes down onto my desktop. So there is the model that we were looking for. So again, that has modeled into 2014 format. As we open it up, it's just going to open up into 2015 format. Now, unfortunately, the first thing you might notice is that we don't get the context site photo with us, which is a shame, but it has a little disclaimer on there that due to restrictions, the satellite image will not be saved. So I'm not sure exactly what the deal was there, but I guess I couldn't negotiate with Google Maps to actually pull the image down, which is unfortunate, but we can get our own context in there. So once we have brought our little mass file into Revit, we can start to have a look at what settings have been brought over. So if I come up to the location inside of Revit, you can see that it has kept our project location to the correct location there. Loads up. There she is, right there in Melbourne, and conveniently it's left our daylight savings ticked on. It has also set up our project north point and whatnot to be correct, so that's quite handy as well. It has brought that in as a mass, so I have to show mass forms. So it's pointed inside of Revit. It's given us true north straight up the page here. So what we need to do to actually rotate this model around is the rotate project north command. So when we rotate project north, that's going to set up the views ready to be drawing correctly and drawing square on the sheet. Unfortunately, when we use the rotate project north command, it doesn't also rotate these mass objects. So if we use the rotate project north, it's done everything except for the mass objects. So they unfortunately also needed to be rotated by the same amount. So it's just something to keep in mind, that it does set up the shared coordinate system as you model it in FormIT. So bringing it back down into Revit, we need to use rotate project north and then also select and rotate our mass object. So this is now coming to Revit as a mass form and can be further worked up. That was not the shape that we were looking for after all. We can look to change that around, get it to be the shape that we were looking for, which may have been our little ellipse shape. Along those lines. and continue to work with that same info inside of Revit. Fix our podium there. Get that out, get it a little bit bigger. Fortunately, we don't have our sites on there anymore, but we can continue to work with that, that same form inside of Revit as a mass object. So then we would do something like potentially import the 3D context if we have that. So as a bit of a, here's one I've prepared earlier. I do happen to have a model that's been worked on a little further. So got the mass model there. Got a few shapes, again our podium shape, a couple of ellipse-shaped towers on top. Worked up from there. And in this one I do actually have the context modeled up. So without, if I untick there, we have the massing turned off. Okay. So we do actually have our 3D context model here from DWG format as the surrounds, and then we have our proposed tower sitting on that site. So again, our office is over here in Collins Street. So we can continue to work with that now. And in context, so I've just further worked up the little podium mass here, cut some interesting shapes into there. So with the massing tools, it's very easy to modify and work with shapes. We're just working with profiles. So on the front profile there, we've done whatever shapes and then extruded that profile out. I've done it with a void. So pretty easy to work with these shapes. So I've just cut one shape with the other here with this void object here. So to change or move the shapes around, it's really quite easy. Simple way to work inside of Revit using the mass modeling tools. And what we can do once we've got a mass built up to a certain level of accuracy, we can start to work with that to do some analysis on the building. So we can do things like calculating the floor levels now. So if I have a look at this shape and have a look at the levels that exist in my project, where were we? South here. So at the moment we've just got a few default or a few levels in there. If I want to create a few more for my tower, I might array that level up. Say that I've got 45 floors odd, and my floor to floor is going to be 3.5 meters. So it's going to throw in my my level lines. Might have some plant up the top, but that's okay. And the beauty of doing the array command is that we can now change the number of levels pretty simply, and also the floor to floor height is also very simple to change now that that's in an array. So with the levels in there, I can then, on my mass, use a special command there called mass floors to cut this mass object with those floors. So select the tool there, choose which of the levels apply to this mass, in which case this is going to be all of them. So that then slices the mass into pieces based on those levels that I've drawn in. So I can see now, hopefully this is coming up clearly on the webinar, that I've got each of these drawn as a mass floor. So I can then select one of those floors and have a look at the properties of it. So here we've got level 39. We can see the floor area. We can see a few other properties and things about that floor. So that's reasonably handy to be able to sort of select one by one like that. Here's the floor for level 22. But even more conveniently, we can start to schedule this information out to start to get, in this case, a schedule would simply show the GFA of the entire project. So gross floor area is a pretty convenient stat to have at this stage. Obviously any changes that we make, that will be updated. But another convenient one that we're going to look at adding in here is the NLA, net lettable area. So I'm just going to very crudely and simply add a core to this shape. So I'm going to model that in place. going to name it core. And I'm just going to place my box here for the core somewhere around there, 30, 20, and that shape. It's got our stairs and everything in it. And then we can extrude that shape up to turn it into a solid as well. There we have, can't really see it there. Core of the tower, I'll bring it down a little more. Okay, so we can start to use that as part of our calculations as well now. So what I've done to be able to schedule the different pieces of info about these objects is just added a wee parameter into the mass floors for whether they are part of the NLA calculations or not. So if I bring this one down, finish the wee core mass there. So what I'm going to do to ensure that the larger overall floor plate is not included in this core is to cut one mass with the other. So if I use the cut tool, cut one from the other, we'll be able to see now that these floor levels have an opening in them, the size of our core, which is what we want. So the area has now reduced. Then from my core, I'm also going to cut the mass floors into that one there. Nope, one of them failed, that's okay. And then I'm going to select all of the core floors and deactivate the NLA option there. So there was my little option, whether it was included in the NLA calcs or not. So I can take that off. It's not part of the lettable area, so we'll just take that one off there. So this is just a little project parameter, custom one that's been added in. So it's a workflow that I've been working in industry, and Franz Hein there, still at Woods Bagot, just been working on this little workflow to get these NLA calcs disappearing there. So that was a very simple core and a very simple building done up there. So now we are able to schedule that information. So if we come down to the scheduling area in Revit, we can create a new schedule, which is a mass floor schedule. I can see all of the different properties about the floor that I might want to add. So we may need the level. We're going to add the NLA, yes or no, property in there, and of course the area, which floor area. So that's going to give us a whole lot of elements here, showing every floor, and it's given us at the moment a double up of every one. So level one here, one is the tower and one is the core. So what I'm going to do is sort by level and untick the itemized each instance box, which is going to sort those into one row, if you like. But then what that does is the floor area does not automatically total there. So we come into the formatting in the floor area, we calculate totals, and there that gives us our GFA. So the core plus the rest of the building. The next field that we'll add in there is to calculate our NLA. So the NLA that we've got there is just a yes or no text box. So what we need to do is add in another field for that's going to give us. We're going to use a formula in this field, and what that's going to do is determine if the NLA box is ticked yes. It's going to give us the floor area. If not, it's going to give us a 0 square meter area there. So, so we want if NLA, the if statement there is ticked on, then we want the area. If not, with the comma there, we want a 0 square meter in there. So that's an area type field. So that has given us that. Oh, also we need to calculate totals on that one. So that has given us all of those values there. Ooh. So if we untick back to itemize every instance. We should be, okay, that's not ticked on, is it? Why not? So all of my mass floors, NLA should be ticked. There we go. That's more like it. Untick the itemize every instance. So there we've got the downstairs basement. No, that's a bit silly. Actually, that'll be all. None of that is net lettable. So ground floor. Here we've got the GFA. There we've got the NLA visible there. So that has got the rest of the tower, excluding the core. And if you had back of house areas and whatnot, it would be possible to continue creating masses and formatting them and getting them in there. Let's change that over to a hidden one, and so NLA, GFA, area schedule can be split down by level. We can get the totals on the bottom of there fairly easily for the entire tower, and then of course that's always keeping up to date as we make changes, as we modify the building. So just quickly, another little piece of analysis, another analysis study that we can do inside of another tool. It's called Project Vasari. It's a free tool at the moment, actually, running till this time about next year. Is we can start to run solar radiation calculations on this mass. So again, we've entered in the information about the site and its location, and so now we can use the analysis tools here to calculate the total heat gain on the surfaces over an entire year. I'll turn on the little solar radiation tool there. So this, you can either Google Project Vasari or look it up there. So what we've got is we're looking for a 1-year solar study. So that's a cumulative solar study over the entire year. Put it into kilowatt hours. And we can select the faces that we want to analyze. So in this case, I'm going to select all of the facade faces there around the outside of my tower, and run this calculation on them. Finish selecting faces. It's going to run that. So we get these colored diagrams with the yellow areas being the hottest and the most solar radiation gain. The orange areas, red, being in the medium range, and the blue areas being rather cool. So if we have a look at this project, there we have the east over here, so we've got the sun rising. Sun rising, we've got our north straight up there, and our west out to the left there. So that is about what we would be expecting from the solar calculations. So this is with this mass, with the context masked up as the DWG there. It is going to take that into account when running those calculations. So you can see down there we have some cool areas potentially from this building next door, shading a part of our project, which is great. We can do some further work with those analysis results, but I'm not going to go too far into it. There is another great little tool built into Vasari, the wind tunnel tool. So all of these tools have come from Ecotech, the previous software there. So this is going to, based on the prevailing wind direction, it's going to show us graphically the conditions on the site there. So at the moment we're just showing the 2D data. We can drag the position of the little slice there to show the conditions around the lower levels, street conditions potentially. Probably got too much context modeled here to see overly accurately that. But here we have the, again, the yellow being the high wind speed, the blue was where we are slowing it down and potentially affecting it with our project. So if I take off the 3D there, you can kind of see a bit more of what we're talking about in context of our job. Go right down. So 2D data is, sure, it's nice, it's great, but 3D volumetric is also available in a number of different formats. Turn on the 3D calculations here. We can see it in a bit more of a point cloud format. It takes a little while, this one. not overly stable, this tool. Again, it's just a beta tool, so sometimes can be a bit finicky. But I guess the coolest is the flow lines here. We can start to see from the prevailing wind direction what the conditions might be around our site. If you get really keen, you can actually pump the number of lines up, cross your fingers, and okay, that seems to be handling that all right at the moment. Again, I've probably zoomed out a little too far and modeled a little too much context around this to really get a meaningful picture out of there, but still we've got those tools available there. All right, that'll be enough for Project Vasari there. So moving forward with our mass, we're turning it into, from a mass to a real building project here. Just going to sort it out. We can use this mass as a base for our actual building design, so we can use some of the massing wall tools to create floors based on those mass floors. So if I select all of those mass floors, say create floor there, it's going to model in in this case, a 150 mil floor in place of just the basic mass floor there. We can also use the walls there, the vertical surfaces, I suppose, as walls. So we'll click the curtain wall tool, set up the options of the tool, and use those faces as the base for a curtain wall system, and also roofs and solid walls as well, not just curtain walls on there. So there we've got a glazing system with millions of 1500 transoms at, what is it, 3 meters or something. So we use the mass as the base for our project there. So let's just go ahead and turn that into a solid wall. So on that, I've just done one here that I've just clicked each of the surfaces around the model and turned them into a curtain wall system and whatnot. A little bit of mucking around, took a little while to click all of those, so I didn't want to bore you with that. But I just get this back to looking normal. So here we have the same project, just with the mass curtain walls applied. I haven't spent much time tidying anything up. I think it's been an hour just on this whole project. So just going around, clicking each of the surfaces, turning it into a curtain wall, and I think I just did the whole podium as a curtain wall also. And my crazy little facade out the front, just some curtain walls applied to the top of that. Couple of beams in there holding things together. So we can now start to produce a few 3Ds of this, I suppose, 3D views, but I will hold off on that. I'll just show all the 3D views at once. Starting to run out of time here. So we can work with this model now, start to cut different levels and floor plates of that. So I've got a level 36 there, but to create a floor plan of this model, we just choose which floor we're dealing with. 20, something up high. 39. Create the view of that floor, and whoop, you can see a bunch of things from my lower floors there. So it's just going to create, at the moment we don't have much info in here, we've just got our facade, curtain wall, bit of a boring looking floor plate. We can now start to work with this model. One of the workflows, I guess, that we could use is to link a CAD file of either if you've got another team working in AutoCAD, or if still you had existing bits and pieces in your AutoCAD library. We can use that information. We don't have to just throw it away, going straight to Revit. So a pretty common workflow is to bring that in as a CAD file for display. So bring in the AutoCAD information there in context of our 3D model. Obviously any facade changes we're keeping up to date. But also obviously modeling in Revit is what we're here to see. So with our Revit modeling, we're using 3D models and 3D walls to do that. I've just been online and searched for some 3D furniture families here to create this floor plate in, again, under an hour. So a few furniture families here that we've got, and a few walls modelled in to represent the design that we're creating here up on level 36. So once that's done, it is possible again to start to use this for the 3D presentation. So if I come back into my 3D view, orient that over to level 36 there, we can see the information that's been modelled up here. So very basic, easy, sketchy model of the project. Just turn those masses off. So we've got our office furniture spread throughout the plan, again mostly just arrayed, probably still a bit of a concept at this stage, some 3D furniture, so we can use the axonometric 3D views here to present the design, but also we can go ahead and start to place cameras down in the model to explore that and see what it's going to feel like in the space. Here we are in hidden line mode. Put that up to something slightly more realistic looking, just changing the settings there. We can go for a little wander around and sort of get the idea of the space across to potential clients. So this is just straight inside of Revit there, but a bit sketchy looking, not really, not an overly high quality presentation. So to create our photorealistic views, we can use the render tools. So we've got still the render button there to render straight in the software here. We've also now got the option to render in the cloud. So I didn't have time to sit here and wait for my poor laptop here to render this project up. So I've used the render in the cloud option, which is going to upload my model up to the cloud and do the rendering there. So just downloaded a few examples of a few renders that I did. So still renders. This was just set to, I think, medium quality. Took about 10 minutes as opposed to about an hour on the computer. So still shots are fine, but the other thing that we can do once we've got the model on the cloud is turn those stills into panorama views. So it's going to take the camera from the Revit model there and render 6 sides of the cube there, and we're going to be able to interactively explore that. And it gives it to you. You can download it in a little HTML format file, ready for a website, or ready to send out to clients, potential clients, or I suppose upload on your own website there. So again, in under sort of an hour, we're able to present some views, and these panorama interactive views are really quite great. They really give the sense of the space across. It's got some junk outside there. And yeah, some really compelling views just straight from Revit in under an hour, pretty easy. So we also had a couple of exteriors. Again, just looking at the underside of that canopy, what it looked like with my curtain wall on it, now super basic context in place, and then a bit of an overall view of the project from standing outside and sort of the feel for the street corner there and our new proposed tower up there. A couple of other presentation techniques that we can use inside of Revit. So we create our floor plan here. New for 2015 is the sketchy lines feature. So rather than it looking like a hard CAD style drawing, we can activate the sketchy lines feature there, and choose how sketchy, I suppose. And that's just going to turn it into more of a hand-drawn feel. It's going to sort of add that hand-drawn look to the lines there. A few options on how jittery the lines appear, how far those little extensions on the end stick out. Just gives it a good sketchy sort of feel there. So with our elevations, we can do the same thing. Any view, I guess. So we've got our south view of the tower, looking very hard and looking very CAD-like. We can create a presentation version of that, turning the shadows on, adding the sketchy lines feature, just give it that more of a hand-drawn feel there. So the cloud rendering there is a feature of being on subscription. So you do have to have a subscription account with a reseller, and you have to have an Autodesk 360 account, which comes for free as part of the subscription option there. So with our other presentation bits and pieces, so we're going to get on to actually looking at documentation now. To the 20 minutes, good. So we're going to look at working this up further. So we've solved the design. It's all beautiful, everyone's on board. So we're going to move into looking at the documentation of this. So with our floor plan that we had there, so in more of a documentation context, we don't want to be running around now that we've 3D modeled or imported 3D models of the items in the floor plan. The last thing we want to be doing is running around and manually either tagging those items, dimensioning things. We want to have that as automated as possible. So rather than, again, typing notes in, what we do in a Revit context is use the information contained within the objects. So within the 3D object there is a bunch of information, and the one that we might be interested in is, say, the assembly code there to show up on our floor plan to identify which piece of furniture is which. So what we can do is, under the annotation tools, we've got the tag item to one by one click the items and click the furniture items and display their tags, but that's might be here all day. So we've got the tag all option here. So tag all, we can just tag all furniture items, for example, with the tag. So if I hit apply there, it's just picked up each of the items of furniture that we can see there, the chairs in that case, and applied that tag to those items. So yeah, a little bit messy there, but sort of got more of an automatic documentation there rather than going around manually one by one tagging those items. Another thing that we want to be doing is starting to schedule out areas within the office, starting to look at what departments are where and what area each is taking up. So done a quick floor plan there. So we've got Revit, this is my nice messy plan. We've got Revit rooms in the spaces. So I've got a room here that's defined by this area, and making a Revit room is going to give us the ability to schedule out things like the area. It's going to give us the ability to put the name in there and what department that lives in. And once we've done that, we can use that as part of our presentation documentation. So all of the rooms are in place. They all belong to a certain department. So we can very easily apply a color scheme to this view. I can add the rooms there. I could be tagging them out, coloring them up by number. It's a bit silly. What we want to do is tag them by department there. So all of the different departments in a different color. And then we can pop our little legend on the side of that so we know what we're looking at. So breakout space there, little color, our circulation area, consulting, meeting, so on. So that's all kept up to date. If those spaces do change, move, we don't need to go around and apply these colors again or go out to Photoshop and move lines and move walls. We've got the information built into Revit. We're just using a little color scheme tool there to display that information. So the last little bit on documentation before I move on to looking at a little bit of scheduling is in our elevation as well. So our building elevations, our documentation there. Again, we don't want to be manually going around and tagging things and documenting one by one, maybe all of these curtain panels here. So rather than going around and clicking each one and saying this is panel type A, panel type B, we can use the smarts of the tool to actually go around and auto-tag that information. So I've just created a quick tag, curtain panel tag there, that just displays what panel type that we're looking at, and potentially I shouldn't have clicked apply, it's going to take a little while. It's going to go around and just any panel that's visible in this view, just going to apply the little tag I've created and sort of more automatically document that elevation for me. Save me the time of manually typing things in. And of course, if things change, that's always up to date. We're not having to go around and re-tag items or find things and chase our tail updating documentation. It's done for us there. Okay, there we go. So yeah, it's just given us just very simple panel type A, type B, type C, D, E, F. I've just done that based on the area of the panel there, but yeah, we could have that based on any one of the properties of the panel or of the facade itself. So we're not having to go around and locate all of those. We could have them coloured up nicely with different colours representing the different panel types and things like that pretty easily too. So that brings me on to the scheduling side of Revit. So we'll start off with our little elevation schedule here. So if we have a look at this here, these are all curtain panels. So again, very easy to create a schedule here of those curtain panels. I've done this one a little earlier. Just created a schedule. So we've got the panel type there as the letters. We've got the area of the combined area of those panels, the area of the facade that they take up. We've totaled that, so we've got total area of the curtain wall facade in that case. And we can start to count the number of the different types of panels. So panel type A, 3,050 of those. We could take this further potentially to add the cost element to it, but more often than not, Revit is used to extract the raw data, like number of panels, and another system might be used to add the cost element to that, because costs are always changing and unique. So pays to be extracting that info from Revit rather than adding the cost info into Revit. Next little schedule that we're going to look at is just the items of furniture in that plan. So again, we don't want to be chasing ourselves around counting furniture items and things like that. We've got it in 3D. So rather than going around and counting or anything like that, we'll just create a schedule of those items. So our one is going to be furniture systems. Very easy to create. Just have a few parameters in there. The description there. We'll put in the family and type of the object. We'll also add manufacturer, description, assembly code. There she is. And we want to know how many of each of these items we've got in there, so I'm going to add the count of each of those. So this by default is going to list out every single thing in the entire project, one by one. So what we're going to do is we're going to sort that by the description there. Not going to itemize every single instance, and I'm actually going to hide that description there. So, whoops. Sort by, oh, okay, we do want this. There we go. A bit more like it. Okay, so we've got all of the, oh, maybe I didn't need that on. So demountable partitions, how many have we got, what style are they? I can't bother formatting that schedule. Go over there, here's one I prepared earlier. So all of the different items, different furniture system items, demountable partitions, there's 270. There are all the different types. There are the assembly codes. There are the numbers of each type of one in there. So the first one there, C10-200, got 8 of those that are the 18-inch style, and so on and so on. We don't want to be going around manually counting these, manually figuring out any of this information. We want to be using the scheduling tools to automatically extract that info from the file. So that is scheduling there. So that is all of the prepared items that I wanted to go through. If you have any questions, now would be the time to throw them up. If you pop them in the question box there. Okay, I'm seeing a few questions there about the audio issues. That is a shame that I didn't see that earlier. Okay, a few things in there about audio issues and whatnot, but yeah. So if you have any questions, throw them into the question box there, please, and I'll attempt to get into those. As I did say earlier, I kind of had to rush through a fair bit of that. So if you did have any, if you did want to see a more in-depth example of any of those topics, well, this webinar is available up on our website. So up on the A2K website under Events and the Webinar Vault, you'll be able to see a recording of this webinar. If you want a more in-depth explanation of any of these topics, please send us an email, so marketing@a2ktechnologies.com.au. If you want to see another webinar on one of those topics more in depth, or if you want us to come out and run a demonstration on any particular topic, we'd be more than happy to do that too. So send through any emails there, marketing@A2K Technologies. So I've got a question here. So can you still change the massing while the floors are in the model, and would it automatically update the areas? Yes, yes it would. So this one here, I've gone and messed around with it. Come back to my little massing study. So yes it would. These areas are live, and so they do update automatically. So if I get my shape here, what have we got at the moment? So level, I've got the actual floor. I'm going to get rid of those concrete floors out of there so we can see. Whoops. So there we have certain level, and if I edit the shape to whatever crazy edit I wanted to do there. Top profile, larger, smaller, change shape. All of those floors are going to update to that, and then all of the areas should follow along too. Trying to make a liar out of me. Finish mass. Having a good think. There we go. All of the floor objects have expanded out into the new shape, and all of the areas have updated there. So that has also updated my mass floor schedule with the latest total area as well. So that's definitely, yep, always up to date. Another question, what is NLA option? So I assume you mean technically how to do that. So the area of the entire floor plate, including the core or back of house areas, is the gross floor area with the entire building, and then the NLA being the net lettable area. In this case, we've crudely cut just our core out of that space to provide that. So what we've done to produce that result is under project setting, under manage project parameters, we've added an option for NLA here into the project. We've said that NLA is a yes/no parameter, so we get the little tick box, and it only applies to mass floors. Well, I've done all the subcategories of mass. So mass floor then gets the tick box, NLA or not NLA. So then we can either one by one or on mass choose whether that is part of the NLA calculations. So now this is not, now it is. So we simply untick NLA on all of the back of house areas and any other areas that are not part of that calculation, and then they're excluded from that calculation when it comes into our mass floor schedule. So there we go, we chose basement was unticked, NLA was unticked. To see that, we can see, I can show again the NLA tick box field in my schedule here. If I untick it for ground floor as well as all not lettable, and then that the NLA count turns over to 0. Next question here, if you have Do you have a subscription to Building Design Suite Premium? Do you have access to the cloud rendering without further cost? So the access to the cloud rendering comes when you're on subscription. So as long as you're on subscription, you can get an Autodesk 360 account, which gives you access to the rendering. Now, it's not a free service, so you get around 100 credits with each license, and so it uses these cloud credits. So one of those still renders costs 1 credit. One of those panoramas costs between 5 and 7 credits. So you get your 100 with each license around about, and then if you use that 100, you pay $150 for 100 more credits. So they work out about $1.50 each. So you say one of those still images costs $1.50, one of those panoramas costs between $7 and $10. So it is, yeah, it takes it off your local computer, renders it on the cloud there for you, but yeah, there is that cost associated. So with the rendering, you can upload a draft, render a draft for free until you're happy with the end result, or with the lighting settings and whatnot. And then when you're ready to go final quality, you put it on high quality, and that's when you pay the $1.50. Can you make, next question, sorry, can you make a mass out of imported files such as DWG or other extensions? Yes, yes, definitely. So that context model that I had in there is in fact a DWG. So this is a DWG file being imported. So if no modifications are needed to the file, you can simply import it into a mass file. So to import the DWG, we come down to New, start what's called a conceptual mass, which gives you the blank template here. You would import the 3D DWG or SAT file or whatever format file in here, and then you import this file and load this in as a family into your project. That way it comes in as a mass, and the Vasari will be able to use it in the solar analysis calculations, and you'll be able to deal with it as a mass. Also, once you've got that DWG imported, one of the newer features there was actually now, in past versions, if you needed to work with that further, you would click explode and it would just disappear. I haven't actually tested this one, but let's give it a go. When I click explode, we should hopefully still see something here in the background that we can potentially, oh no, there we go. Bad example. But in the newer version, no, I think I created this file in 13. When you do bring in potentially a simpler context file than this one, we can use the explode feature and then continue to work with that geometry. So we can use the endpoints of it, we can cut that with voids and whatnot. So that's one of the newer features, might have been new for 14, that we can then further work with the DWG or other formats. The next question there, so does the solar radiation calculation have a certain formula? I'm not quite sure what you mean by that. Certain formula. So it's based on the Ecotect engine, that the Autodesk Ecotect product. I'm not sure what you mean by formula, but it is. It does calculate the as we'd set that calculation to do. It is calculating the kilowatt hours per meter squared of solar radiation hitting the surface. So we can play around with that. It does actually give you a little legend, usually. This little legend that gives you the minimum and maximum. Now, whether that's 100% or not, I'm not sure. In previous experience, we had used this tool as a comparative analysis tool. So we had produced the diagram with the hot areas in yellow, cool areas in blue, say without a shading solution or a facade solution, applied the fix, say the solar shades, or rotated the building to suit, and then run another solar radiation analysis just as a comparative analysis. So here it is yellow, bad. Here it is now blue, good. It does give you the exact values in the little legend. Not sure why my little legend has disappeared. There it is there. So it is telling us that the hottest point is 541 kilowatt. Is it now? Yep. So 541.6 kilowatt hours per meter squared over the whole year. So I've done a 1-year cumulative solar study. So it gives us the time and date. Oh, did it for last year. That'll be fine. So we can do it over 1 day, over 1 hour or whatever. We can start to turn the shadows on again in here, just like in Revit. Set our little calculator on there. Start to look at what the effects of the shadows are on the building, and we can run a solar radiation for just at that one time of day, rather than the full year. So just here, just at this time of day, whatever time of day I set. I've done the whole day, sorry. Still at 12 p.m. There we go. So at that time of day, what are we getting? Okay, we've got this exact here, and the sun is up and to our right. If I turn that on, there's the sun. We can see what the shadows are doing, if need be, how they're interacting with the building. We can see this building here is providing shade to this area of our proposed building. So therefore, at this exact time of day, there's no need for shades in that area. But of course, the more useful study is the entire year solar study, that we're actually multi-day, 1-year solar study, so that we're getting all conditions at all times of the year, and that's a cumulative solar study there. Thank you. Does the what about wind calculation? Someone has popped in there. So I did show the little wind tunnel. So the wind rose that we can pop on there is going to be accurate for the location. It's going to give us the prevailing wind direction based on where we are in the world that we've set. And then when we activate the feature there called the wind tunnel, it's going to put that automatically put the wind direction coming from that prevailing direction, and then we can modify it from there. So again, if I take off the 3D displacement there, pop that 2D slice down lower in my project, I can start to see the conditions around my site, what we might be getting. Again, I haven't got the entire of Melbourne modelled up, just my little piece here. And so we can, the orbit controls are a little different. There we go. So we can see, you know, straight up, what is that, William Street. We're getting the wind blowing up. So now our effect is that you've got this area here of lower wind speed. We can bring that slice up and see it at different levels. I guess what we're interested in is the streetscape. And then we can actually change the wind direction. So if we know better than Revit where the wind's coming from, we can change that prevailing direction that we're interested in, see what happens from the different directions and whatnot. So here we've just got, again, high and low wind speeds. And so that was our little 2D. We can do the fun one, which is throwing that onto 3D representation and representing it with, I guess, flow lines is the clearest representation of the wind. We can see the arrows coming through representing that wind. Point cloud, flow lines, here they come. So let's see if we can get that looking a little better. Whoops. Let's go for, oh, and let's throw on more lines. Okay, start to see the effect of our tower around. Again, you need to crop this down and have a smaller region there that you're viewing if you really want to get an idea of the immediate environment and what you're doing to the streetscape there. But so this was all Project Visari. So it's a free one, you can download. It is a beta, so it sometimes does crash, but a great little tool that's available at least until July next year. So all right, if that's all of the questions, thank you very much for attending. And again, if you want to see more or have another an idea for another webinar or a more in-depth on any of those topics, please let us know at marketing@A2K Technologies.com.au. Thank you very much.